Okay, what I'm talking about, it's not just data. Metadata is data or metadata, the DNA of a data architecture. So I guess for you, for the audience, it's a kind of different talk now. All the other talks about predictive mining and all the fancy stuff. Now, who I am? I'm Dirk Lerner. I'm doing a lot with data modeling. You see it over here. That's a data model. It's an abstract data model. But that's enough. You can follow me on all the stuff on social media, and you know it better than me. So what I'm talking today, cells. Cells using DNA to do their jobs. They know when, how, and what to do in something like a human body. So this is a picture. I have to thank the IMP for allowing me to use it. It shows you how a cell shares or divides itself into two new cells. And what are they using for this? They know it from the DNA. The DNA itself stores all the information for cells to divide, normally to reproduce in the same cell. They do all the time the same, share it, it's like a copy of themselves. But sometimes they know when to do it slightly different, to get another cell to restructure a little bit. And what I want to show is metadata also a DNA in a data warehouse environment, for example, in a data architecture? And before to dive deeper into this topic, you have to know what is metadata. And first, let me cluster it into different kind of metadata. In this context, I'm talking about a data architecture. There are several different contexts where you can show metadata or define metadata. Business metadata is everything about a semantic description of your attributes, of the things you want to store somewhere or you want to describe in a business sense of definition. Storage metadata is everything where you store data in database objects, in files, and everything else. Then we have some process metadata because we have to process data from A to B from somewhere else, also known as data logistic. I call it data logistic metadata. And the next thing is we have some display metadata. I saw here many different devices in the audience, and if you want to do some kind of reporting in a data warehouse environment, the report has to know how it should look like on the different devices. You know, responsive designs of a website can look totally different on a mobile device than on a laptop. And the next thing of metadata we use in a data warehouse environment is some project metadata and the program metadata. I don't want to dive deep into this because of the time. So next, let me show you a very simple data warehouse environment. It's shown as a data flow from left to right. Left, you have the source systems. In the middle, you have your data warehouse, and then you have some fancy stuff. And at the end, you have your data where you can access and use the information to make some decisions. And then we have to ask, which metadata at least do we need to build or to drive the data warehouse? And therefore, first we need some storage information about where do we get data, where is it stored, and where do we have to deliver it, how does it look like, which format does it have, and so on and so on. And this is a logical view on a metadata model. And then the next thing is we have some data logistic meta information. So we need to know which elements with instances of an entity we have to transport from the source, for example, to our core data warehouse, to our access layer, to a report. So all the data has to flow in a kind of way, and that's the data logistic. And there also we store the information about the data logistic, the statistics about the data logistics. Okay, I don't dive too deep into it. And then we have some metadata about the business rules. It's also part of the data logistic. If we massage the data, if we transform the data, if we do something with the data, like all the speakers before showed, they transform data, use it for something else, we have to store it somewhere. And then we can think about where can we automate with this information our data warehouse. And that's a very interesting thing that we say all the metadata, which is stored here in this layer, we can use to automate our transport processes, our ETL, our storage information, and also our virtualization models on top of it. And that's what I call the DNA. You can document, you can navigate, and you can administer all the stuff in your data warehouse environment. But then, what are the cells? If the metadata is the DNA, what are the cells in your data warehouse? And now you get in short yeah, okay. I will show you very short how Data Vault is working. Data Vault is a physical implementation method for data modeling, for storing data in your warehouse. And Data Vault is very good for automation because it exists of patterns. Yeah, like I said, the back knopf here, patterns like cells. So we have different basic elements. I do not deep dive into the rules. So we have a hub. A hub stores all the business key information. If you have a core business concept like a customer and you want to sell to this customer some articles, you store there your customer number or your article number in another object. That's all. Nothing else. No time, no context, nothing else. The second one is a pattern where you make the relationship, the business relationship between your key concepts. Like a customer wants to buy some articles in your shop. And then you have a link in between, and the element is called link. Oh, that's very simple. And the next stuff, because you have nothing, no information, no context information about your key concepts and your relationship between key concepts, you store this information in so-called satellites. And you have a satellite customer. There you store, for example, first name, last name, the address, and the historical information, because here you make all the versioning. If something is changing, then you make a new row, you insert a new row into this type of element, and that's it. Some reference data. And if you model a nice model, data model in your data warehouse, it looks like this. So you have your hubs. You have an employee, you have a customer, and a store, and an employee sells in this store something to a customer. So that's how this kind of data modeling methodology works. And you see, we only have these 3 types of patterns in your whole data model. It looks all the same. All the hubs have the same patterns. Here, these squares. All the links have the same patterns, so it's all the time the same. Nothing is changing. It's like a cell is dividing into 2 objects. And why is this interesting? Because if I want to load now data, all my key business concept into the hubs, all these circled objects here, I can use the same load pattern to store the data for the data logistic, and I can really easy reuse this kind of pattern. So I took my data from the source to the staging area. So if you want to dive deeper, come afterwards to me and I will explain it to you if you don't know it. And you compare, for example, your customer number with a new customer number. It's arriving in your system. And if you have it already stored in your hub, then there's nothing to do. If you have a new business key, a new customer, you store it in your data warehouse. And then you know I have now this amount of customers in my data warehouse. The next thing is the links, the relationship between customers, articles, and so on. It's also the same pattern. You have a very similar loading pattern again, and then you load the satellites in the next step, and you also have a similar loading pattern. And then there's a special satellite at the link, but okay. That's very short now how we store all this stuff in the data warehouse. You see, that's all in the model. We can store the employee, which stores, which sales, with products, with vendors we have, and so on. Now after that, we have the data in the warehouse, but we have to get it out. We want to use it in any way. So there are some different techniques like star schemas. You can get out very fast data for reporting, for analysis, for predictive analysis, and so on. You can use different access layers to your data, and one of it is a star schema. It's a very simple one. And there, if you can do a drop table test, I call it, so you can throw the tables away, recreate it, load the data very easy in it, then you are at a point where you can say, I can virtualize all my access layers. So it's in the agile sense, you can deliver very fast new access layers, new models to access your data. So drop the tables, recreate the tables, and that's it. So now we have a lot of learned about patterns. That's very fast introduction into data modeling, and about the metadata. Now we want to use and generate this information, these patterns and the metadata to deliver faster new data marts, new reports in our data warehouse. And let's say you have this data model. It's the AdventureWorks data model from Microsoft. You can download it somewhere else. And you use a tool which you want. Here is an example with Power Designer. I modeled it as a data model, and you can extract it from these modeling tools, Irwin, Power Designer, Embarcadero, what else you want to use, and store it in your metadata. And that's what you can say, you fill the DNA of your data warehouse. And with this DNA, you can automate a lot of things. First, you can automate the loading processes. That's a natural part in a project that people say, I don't want to code all the time the same and the same, and just replace source and target and the attributes, and therefore I try to generate it. The next step is, and the next step is you can generate your data model, for example. If you want to automate this again, you can say, I just deploy metadata from my development environment to my test environment to my production environment, and I do not need to deploy any other objects anymore. So, and the last thing you can generate with the metadata is the virtualization layer, for example, for access purposes, and then easy access your data. Target is to generate as much as possible in your environment with the DNA of your data warehouse. So, as I mentioned, you can hear the ETL processes. It's easy to generate. That's normally and naturally the first step in a project you want to generate. Then you can generate all your data objects or your virtualization layer at the end of your data warehouse to get really easy to your data. Summary. So I was very fast now because I didn't explain too technical the data modeling stuff. At the end, we can say in a data warehouse we have patterns. That's at a human being like cells. We have the metadata. It's like the DNA in our bodies, in our cells, and metadata helps us to find out how to build your elements in your data warehouse, where to build and when to build. And the same is on the human side. The DNA tells your cells how to build, where to build, and when to build. And then I say the data vault, the data modeling methodology, and the ETL processes are kind of muscles and bones because the data model itself is like bones in your data warehouse, and the ETL processes decides how strong is your data warehouse at the end. And then with the virtualization, you can, like at skins, at human being, make very different access layers, create different sites on your data, and that's what I call virtualization. Virtualization is like skins of a human being. So that's why I want to show you, want to give you a way this evening if you want to dive deeper into this kind of topics of your data, what you can do with your data in a classical environment, then feel free to come over. At the end, I have to say the DNA, to come back to the question at the beginning, is metadata, the DNA of a data architecture. I say, yes, you can use and build with metadata each and everything in a well-defined data architecture for your data warehouse environment. Thank you very much.